influences weather patterns across the world, from America to Antarctica to Australia. From the Spanish for little boy, it's known as El Niño. Its other cycle is La Niña, or little girl, with the in-between phase called neutral. The swing between these phases forms the El Niño Southern Oscillation, or ENSO, one of the most important climate drivers in the world. ENSO is a major influence on Australia's climate. El Nino and La Nina events can cause natural extreme events such as bushfires, drought, heat waves, floods, and cyclones. As the Earth spins, trade winds stream across the planet, driving warm surface seawaters across the vast Pacific Ocean. These sea surface temperatures create predictable patterns of circulation in the atmosphere and ocean. Climate scientists gather data from ships, weather stations, ocean robots, and satellites to measure the swing between the three phases of ENSO: neutral, El Niño, and La Niña. A La Niña event tends to bring above-average rainfall to eastern Australia. During an El Niño event, there is a greater chance of drought and bushfires. Each El Niño and La Niña event lasts about 6 to 12 months. It takes, on average, 4 years to cycle from El Niño to La Niña and back again. But no two El Niños are the same. The strong 1997-98 El Niño impacted every continent in the world, causing widespread devastation worldwide. This story begins in the eastern Pacific. Here, trade winds blowing from east to west push warm surface waters across the planet, piling up warm water in the western Pacific. Above the ocean, warm air rises, driving atmospheric circulation patterns known as Walker circulation. Cold, nutrient-rich waters upwell in the coastal ocean, replacing the warm water pushed away by the trade winds. Like an athlete pumping iron, the La Niña is the muscled-up version of the neutral phase. Trade winds become strong, and more warm water builds up in the West Pacific. The excess of warm water increases evaporation and precipitation, causing floods and forming tropical cyclones off the northeastern Australian coast. This warm water escapes through the gap between Indonesia and Australia to supercharge the Leeuwin Current, a 5,500 kilometre long flow of warm waters along the Western Australian coast. But, like an athlete, the winds can't keep pumping at this speed forever. Sometimes the winds weaken and warm water sloshes back across the ocean to the East Pacific. The Walker circulation breaks down, weakening or even reversing the trade winds. Warming of the Eastern Pacific accelerates, setting off a feedback loop that keeps most of the rain-producing evaporation in the middle of the Pacific. Due to the movement to the east of warm surface waters, northern and eastern Australia experience clearer skies, higher temperatures, heat waves, and increased risk of drought. Off the coast, fewer tropical cyclones form, as tropical activity is concentrated further east. Off the coast of South America, upwelling of cold waters is suppressed, and warmer surface waters result in higher than normal rainfalls and sometimes flooding and hurricanes. In Western Australia, the Leeuwin Current tends to be weaker and cooler during El Niño events. During the 2010-2011 La Niña, marine waters that were up to 5 degrees warmer than usual caused mass deaths of marine life, as well as coral bleaching along the Western Australian coast. However, warmer La Niña waters are generally beneficial for species such as the western rock lobster, whose larvae ride the Leeuwin Current southwards. In La Niña years, more lobster larvae settle to the ocean floor, meaning greater numbers are available to fisheries. 2015 is the first strong El Niño in 18 years. In the future, understanding when, how, and why these events happen will help us to manage the risks that they bring.